Now we'll go for analysis, and before analysis we have to complete some tasks, like we have to mesh our slab, then we have to add support here. Okay, and then we have to select our load combination, and we have to select our code, for which code we want to go for design. Then we'll go for our final analysis. Okay, so let's go. To change your support system, first of all, I'll go to plan. I'll select all of them or support, and if you are not here, just simply by clicking on the supports option, just come here. Okay, now you'll see here 12 nodes have been selected, but although here 11 support is available, but it's showing us a 12 node, so nothing to worry, because only we are selecting here only our support on in base node. So what I will do, after selecting that, I'll go here, the option support, and from here I'll select support fixed. Okay, and you can see some option already selected here. Okay, so what I'll click apply, and I'll go view, and you'll see all of our support have been changed. So this is the simple way to change your support system, and also you can change it base, then fixed, and then pinned. Okay, I'll close it. So after that, I'll go for meshing. So before meshing, we'll go to tools, job preferences, then meshing, and here I'll stop this option, kinematic constraint in inherent point. I'll close it, then I'll click OK. Now I'll go for our next step. They have option. If you click here, option of FE mesh generation, I'll click here, and they have option meshing option. They have many options actually available, but I will use this option, meshing option. And no panel selected for the operation. Do you want to perform those operation for all panels? So panel means slab. Yes, I want to perform for all panels or for all slab. Yes, then they have some option. So automatic selection of meshing method. Yes, then mesh generation, it is it's showing for 3 feet. Okay, let's take it 3 feet, or we can take it for 2 feet 24 inch, or you can click here for automatic. So I'll click element size, let's say 2 feet, and I'll click here for the additional option. And from additional option, it's 2 feet. Then what will be the color, then ratio, it's recommended. Also a triangular and a square in Walker, then fractioning ratio, any, will not do anything here. Just click here any, then as recommended 4 node, then 4 node quadrantal. I think it's okay, then click OK. So done, our meshing have been completed. We have meshed our model. I'll close it. So they have option, sorry, maybe load system, panel interaction. Okay, so now we're ready for analysis, but before analysis we have to add load combination. As is, it is a 5-story building. First of all, I'll go for only gravity load. Then in our another lecture, I'll go for I'll go for our earthquake load. Okay, earthquake and wind load. So to do it, I'll go to our loads, then manual combination. So I'll take its name is 1. Here 1. Already you know that how we'll do it. Okay, because in our previous lecture I have done it. So in the same way I'll complete that. Okay, so to do it, I'll open our Excel sheet. I'll use this combo 1.4 dead lot. So first of all, I'll create a combination of dead lot. So I'll take its name as all dead lot. Okay, all dead lot. Then I'll click OK. And from here, I'll select only dead lot. And you'll see the list of dead lot, and its factor will be 1 for all dead lots. Otherwise, we can ignore it. We can click here change. We can give its name is 1.4 dead lot. Okay, then click OK. 1.4 dead lot, and I'll provide the factor 1.4 with all data. Done. Then click apply. Okay, now I'll go for next. We'll go for next, and what will be the combo here? This is the combo. I'll copy it. I'll come here. I'll paste it here. Click OK. And here we need 1.2 dead lot. So 1.2 dead lot. So dead lot is selected here. Press Ctrl and click here. Then click in that side. So 1.2 dead lot. Then sorry. Okay, now I'll click here for our 1.6 live load floor. So I'll go for live load L unreducible. This is live load floor. .6 live load floor. Then add it here. Then go for live load roof on 0.5 live load roof. So what will be the live load roof? Our snow load, or we have defined that live load roof as a here LR roof live load. Then select it, and for 0.5 take it here. Done. Then click apply. Okay, done. Now we'll go for our next step. So what will be the next step? Our next step will be next combination. Here, copy it. I'll copy it, and yes, I want to save. I'll click new. Give it here. Click OK. Okay. Now what will be the dead load? Our same dead load will be 1.2. Select that 3 with 1.2. Add. Then 1.6 live load roof. So here is the live load roof live load. Select, sorry, 1.6, select it, and then 1.0 live load F. 1 here live load 1 times of live load floor. I mean our basic live load actually. Done. Then click add and apply. So we have created 3 load combination for this time, and further we'll create our other live load combination. For my case, I have selected load combination from my code. For your code, you are able, or you are absolutely free to select combination from your code. Okay, and if you have any recommendation that how we'll create load combination like that, so you can let us know. I'll try to do it. Again, I'll go here and click here. So actually I have selected automatic selection of meshing method, so we can go for complex mesh generation. It's also better. Then if you click complex mesh generation, then you will get this option method parameters, and they have option regular mesh and refinement mesh. Okay, so they have two options. You can select any of them. Okay, and I'll uncheck it so that we can go for regular and also irregular. Then click simply OK. Done. We have completed our meshing. Now we'll go for next option. So what will be the next option? I'll close it, and now we are completely ready for analysis. But before analysis, I'll save this model. I'll click a file, save as, not save, save as, and I will go with ASCE. That means I'll design this structure with ACI and ASC, and when I'll design, I'll take our previous model as a default format, then simply click save. Okay, now you can see here our the new saved file have been opened, and our previous file, if I go here, open project, you will see this is the previous project or default project, and here now recently we are working with this. So I'll close it, and they have option calculation or analysis parameters. You can click here for analysis parameters, that for what you are you want to go for analysis. Okay, otherwise we can simply click here for calculation, or they have option analysis and analysis type or calculation. Simply click here calculation, and our analysis will start. Isolated node have been found. Do you want to continue? Yes. Isolated node additional attribution found. Do you want to continue? Yes. In established type 3 detected at node 10 in direction. Okay, so why this happening? Because they have a extra node. They have an extra node which are not selected as a support. That's why it's showing. So nothing to worry about it. Just simply click yes. Okay, so there have some issue, zero error. They have no error on our model. But if you go here, you'll see the element is defined on a story different from assigned on here. You can see here it's marking here. Okay, so nothing to worry about it. And again, okay, if I, what is it here, our staircase actually. Okay, now I'll go for our next step. So the load has not been distributed correctly. There are no object or elements, so I'll check where this is happening actually. Okay, I'll click here. Okay, I'll click here. So for that member, it's showing this warning, so nothing to worry. We'll solve it later. Then they have option isolated node have been found. I'll click here. So where is the isolated node? See here, I have told you that they have a node where we have found the isolated node, and they have here we had 2 points actually. That's why it's showing. So nothing to worry on it. Then isolated node with additional attributes found in the same position. Here the instability 3 types in UZ direction in node 10. So in node 10 we found something here, and they have no warning. And if we go for number of warning, so total number of warning is 6, but they have no error, so you can close it. Now okay, and we can stop this option, extrude mode. I'll come here, and I'll go to result now. So for result, I'll click here result, and they have option result diagram. So first of all, I'll go for result diagram. Here our result diagram. Now there are many options. For which option you want to go? Let's go for FX first, and click apply. you'll see it here. Okay, here. And for which load actually you want to see, you can click here. So if we want to go for let's say this case, if you want to go for this case, if we want to go for this case, we'll see it here. Now let's say I will click this grid and I'll click here for this single grid, and you can see all values available here at the axial force. Then if I go for this value, I'll click apply. So here is the axial force, and this showing in big scale. So what I'll do, I'll give here 1000 and click apply. Okay, so I'll go 15,000, click apply. Also I'll go 35,000, click apply. So press Ctrl to check this value. So this is the shear force actually, FZ force in Z direction for this two member. And if you want to see the value for column, then we have to go for FX, click apply. I'll increase this value to, let's say 16, then click apply, and I'll uncheck it, apply. So here, okay, here. Now I'll go here for another thing, deformation, then a stress, reaction. Okay, so if you want to see the reaction, I will first come here, click here for the first one. Okay, if you want to see the moment, let's say we want to see the moment for MZ, and click apply, we'll get the moment here for MZ. Okay, and if we go for, okay, no need to change the color. If we click here, this is the moment for our beam. This is the moment for our beam. And if you want to see the value actually, we can also go for it. Click here, parameters. Then from parameters, click text and field. Okay, let's go for the 2 point. See here. So this is the value of our model. So you know, we'll get this value in pound. You know it. You'll get this value in pound. So I'll click. So LB feet. Okay, our value are in LB feet. So here we are getting our all values. Also, if you increase this in 9 and apply here, actually it's totally depend on you that how we'll customize this Excel. Sorry, scale. Click apply. Okay. So here is the value for our model. For two maximum are showing for positive and for negative. For positive and for negative. So here our value. And also if we go for MX here, this is for our beam. Here also MX, and if we go for M here. Okay, so now I'll close it, and if you go for MZ, you'll get the value for columns. Here the value of columns. I'll close it. Now if you want to see the deformation, then you can click here, nodal deformation, or deformation in a structured scale. You can click here. So I'll click here, and I want to see in UZ direction, then click apply. Okay, before that okay, it's off. Here the deformation actually, so where how much it's deflecting, it's 0.01 inch. It's deflection are in inch. You can see here 22, then here 0.24. This deflection is very less, very low actually. Vertical deflection for this time 0.015. and if you want to change this 4, then click apply. That's 8. here. So this is the deflection. You can take your deflection for overall structure. Okay, now I'll go for we can exist it. So I'll close it right now. Exist it again. Okay. So if you want to go for, let's say, if you want to go for draw, or if you want to go for Studio 1, and if you click here, we'll see the value of Studio 1 here. Okay. Now, sorry, here we are seeing diagrams value, not for our slab. So when we'll see the value for our slab, we'll use another option, that is map. Okay, result for map, this option. So I'll also close it, I think. And if you want to see the stress of the member, and click here and click apply to see the member. And again, if you want to see the deflection same as previous, then click apply. You'll see the overall deflection of our structure. Here you can see the overall deflection is available here. And if you want to, if you click on animation, it will give you the animation here also. See, here is the animation of this deflection. So you can change this scale to see your movement, or to see the movement of the structure. So what we'll do, I will close it. Now if you want to see the stress, and if you want to see the reaction also, you can see it. So to see the reaction, simply let's go for YZ reaction, then click apply. Here is the member for this reaction, but if I come here, parameters, show value in text, then okay, click apply. Click here field. Here okay, I will, for deflection, I will uncheck it first. I'll uncheck it, click apply. Let's see anything is opened. No. So we'll go reaction, then FZ, local system, diagram for linear support, average. Okay, so here again, I'll come here, parameters, field, then level and values, positive or negative values. I'll click apply. Okay, so if I go, or if I change here something like for self weight, so here FZ, you can see for every node or case, this value is available here in our table. Actually, if I go reaction, FZ, FX, click apply. So for every direction, we're seeing that we're seeing the arrow, and if you come here, you'll see the value for every node of this structure. But only we know we need the value of a different node. So if I click here, node number, if you click on that node number, we'll see the node is the 1, is the 2, is the node 9. So for node 1 is the node 1. Okay, and here's the value. This is the value of fx, fy, and this is the value for fz. And if I click here for self weight, okay, is on. Then if I change for live load floor, this is and then click apply. lab.floor, and I'll stop the node. Actually, this is the way to find out our all values, or to see all values here. And as per your requirement, you'll see everything. But right now, I'll go for our slab value. I'll go for our slab value. So I'll click here for map. Okay. And actually, before that, we have to change or we have to stop this value. So for that, I'll come here, diagrams, and from reaction, I will stop this. Residual force, this is not available. Okay, this is also not available. So okay, done. Now I'll go for I'll go for map. Done. And here, what you want to see, I want to see for, let's say, detailed displacement. Here, the values, or see map also. Click apply. Here, you can see the displacement, and if I change it, it will change with our combo. So if I go for combo 1.4, see here, this value is also available. Okay, for panel slab or panel member only actually. Then I'll go for YY. So if you go for YY direction, click apply. This is the value for YY direction, and you'll see for case 1.4, automatic direction case 11, and for 1.4, this value is in inch, and the deflection in YY direction. Okay, so here the value, all values are showing here. You can see all values are showing in every point. And also, if you want to see for a specific panel, then simply, let's say, if you want to see for 4, or if you want to see for, let's say, sorry, if you click here for a story, let's say I want to see for a story 1, click a story 1, then click here, and only story 1 will be available here. Okay, and this is the panel scale. And if I go for click apply, here you can take the mouse to see the value. Okay, everywhere. And in this panel, we are getting a huge deflection. Now smoothing with panel, global smoothing. Okay, and smoothing according to selection. So this smoothing with panel, you can change everything as per your requirement, but I think no smoothing. So if you click no smoothing, it will give us another types of value. And if you click here with mesh, click apply, so you can see this value are showing with mesh. Then I'll close it. And if we go for shear force, okay, if we go for shear force, then okay, I'll check the displacement in Z direction, click apply. Mainly our most of the, I'll click this option, I'll show values, click apply. So if you take mouse, you will see the deflection are showing on our every slab here. Okay, I'll stop this option, view with direction. I'll not see view with direction here, only with normalized way, and everywhere I am seeing where is the most deflection are showing here at the middle, and also here at the middle, also here 0.15, 0.09, 1 on. And for every and each point, we're seeing that. And with FEM here, values. So if we come here, we can see in that point we have used deflection, or the maximum deflection here actually. So I hope you'll be able to, and they have also they have many well, so principal, complex, parameters, what you want to see, or scale here, everything is available. When you'll watch this video and when you'll practice, then you will understand everything in details. So I think it's done. I'll close it. Sorry, I'll click here to close it. Done. And we have to, when our analysis have been completed, then we have to check for our model of deflection. I think it's okay right now. Now I'll go for the next one. So what will be the next one? We'll go for our design actually. Okay, so here the details and detailed analysis. So if you go here for detailed analysis, also you can take your value the same as previous. So this is for our member. Okay, I'll change it in map. I have to stop. I'll go to detailed. I'll stop this option, click apply, done. So when it's done, now I'll go for our design process. Okay, so what will be the design, or what will be the procedure of design? To complete the design, I have to go here, RCC design, here RCC design. So I'll click here for RCC design, and in RCC design we have many options. So what you want to design? Slab provided reinforcement, slab punching. So as they have no slab over the column, so no or in the column, so no punching will be available. Slab reinforcement, I only need right now the RCC member. Okay, RCC member. So what will be the RCC member? Beam and column actually. Now I'll go for RCC member, record reinforcement. I'll click here. Okay, now when we are here, then I'll click here for our combo list of case. So for what combo we want to design actually, that many option member. So wall member, or you can select some member. So I'll select all member, and it will be design, and they have capacity verification option. So I'll first of all I'll go for design, then all member, and the all member is selected. So all of our member in this model will be selected, and the code combination. Most important, we have to select the code combination. So ultimate, I'll select here, I'll come here, and from here I'll select our attributes, not the case. So this is for dead load, and I'll select this all load and click here to select. So 1 to 7 have been selected. Okay, the list of case. Then I'll, when it's done, okay, then click close. So it's done. We have selected case 1 to 7. So for 1 to 7 our structure will be designed, but we want to go for combination, not for case. So I'll click here again, then uncheck it or delete it, then click here combination, and only 3 combination is available here. Then simply click here and see 11 to 13 combo have been added, then close, and you'll see this 11 to 13 combination have been added. And then simply, and they have option calculate beam in 5 points. So I want to design a beam in 3 point, in 2 support and middle. That's it. Or they have every they have another option that in every after a specific distance. So no, in 3 points. Okay, done, and simply click calculate. Our design process, sorry, our design process have been started, and you can see the for detailed information about error and warning display the mark column uh, so here, result of calculation for member, these members are correct, and this member have contains some warning, so nothing to worry about it, and we have no error actually. So, and for detailed reinforcement actually, as they have no issue actually with error, we can close it, and you will see the earning again here. So now if you come here, you will see the reinforcement detailing. So how we'll go for actual values, I'll click here, I'll select, sorry, I'll click our story 1, let's say, and from here I can stop seeing our panel description. I'll not see, then I'll stop also meshing, then I'll not see the panel, I'll only see the beam. Okay, and here it's selected, and click here to see it. That's it. So here, and also I'll see the member number, say the member number. Now here are member number, and I'll go for reinforcement detailing. So here is the move it, member number 12. So first of all, let's say I want to go design for 46 and 47. So I'll go down here, our 39, this is the 13. Actually, when you'll select, you'll see the selected member is available here. So if we go for 39 and 40, and here is the reinforcement, and you can see also top reinforcement. You can see the top reinforcement also, top required reinforcement here, or the top required reinforcement in 3 point. So here for 39, the first point, and the middle, and this is the left, this is this point, and 5.79 is the middle point, and 10.58 is the last point. So it's giving us the reinforcement for this point. We are getting 1.0 inches square. Then we are getting reinforcement for here also, we are getting at middle 0.36, and here, so you can see the reinforcement also, the reinforcement is seeing here. So 2 number 8 reinforcement at middle. Okay, so if we go for bottom reinforcement, actually in MI, for MI actually bottom required reinforcement, this is the top required reinforcement actually. So you can see they have provided 2 reinforcement in overall direction. Okay, but don't do it. I will check on this value. I'll check on this value, and then I'll go for different design. Okay, and they have taken number 8 bar to number 8 bar. Okay, so I'll not do it. And here also, here at middle, at bottom, it's required 1.02 inches square reinforcement, and here it's 0.36 in on-site, and another set no requirement. Okay, and also they have provided 2 number 8. That means over the beam, in overall beam, the software have considered in top and bottom, in top 2 number, 2 nose 8 number bar, and in bottom 2 nose 8 number bar. Okay, here for every member you can see it. So when we'll go for a real project design, then I will show you that how we will consider this reinforcement, and how we'll provide the actual required reinforcement. Okay, so, and if I go here, you can see in every beam it's showing almost the minimum, sorry, it's showing the minimum reinforcement. And if you go to the transverse reinforcement, it's also showing you the transverse reinforcement here. Okay, so close it. Now if we go for column, let's say here the member 1, this is the member 1, so I'll come here. Actually, now this value, this is the value, or a value for 12 for beams are showing. So if you want to, here you'll see the beams are selected, all beam are selected, and if you click here for our column, you'll see the value of column, what's materials or what have been selected actually. Okay, now if you go for beam info, you'll see the beam info for what beam it's design, total number of beam, selected beam, then go for column. So if you go for column, we can see here in record reinforcement along B it's 0.45 and in H 0.27. So here also we need 4 reinforcement. Okay, also we need 4 reinforcement, and here the number 2 bar 414 at that 5 inch center to center. So actually here's the reinforcement also for transverse reinforcement, or and if we go for column info and if you go for general, you can see which number of column are failing. So here this column, you can see here column number 34, column number 34 it's failing, and column 1 2 3 are also failing. For which design case 1 2 3 case type RCC. Okay, a several number of column are failing. Okay, so what we have to do, we have to change the section, or we have to increase the section size, then it will pass, or obviously. Okay, so this is the way to find out the column reinforcement data, or beam reinforcement data. Okay, and when we'll go for our main design, or I will select a real project, and then I will show you everything. I'll show you in more details actually. Thank you very much.